if you looked in the book, chapter 3, it started out with a picture of a mass spectrometer. All right? A mass spectrometer. And this kind of shows how we get the masses of different elements and isotopes. So I've got a ramp here. I made this, and I've got a ball. And what I'm going to do is I'm going to roll the ball down the ramp. Pretty amazing, right?
Yeah.
Wow.
Roll the ball down the ramp, and it, for the most part, hits almost at the same point every time, right around there. See? Okay. I also have a marble. All right? I'm going to roll a marble down the ramp. The marble has a different mass, so it hits at a little bit of a different spot. I'm trying to drop it. I'm actually going to go halfway. I should have done that from the beginning. We're going to go halfway down the ramp. So right now, this is just me rolling a ball down a ramp, and you're like, what is he doing? That's okay. All right? I'm kind of trying to do this fast. Now I've got a metal sphere. Actually watching this closely. All right, I'm rolling it down. Did anybody see that? What the?
Oh, it's because you have the front.
Hold on. So this is now hitting here. Okay, so this is hitting like right around here. I'll use a different ball, a little bit lighter. This one's hitting a little bit further out, kind of. It just hits differently. Just hits differently. Smaller one. Oh, snap.
Whoa.
What in the... All right, this one's hitting all the way down here. This is not black magic. All right? I've got a really small one. Anybody guess what's going on here? Whoa, 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 whoa. I didn't even go the right way.
I was gonna say what? Whoa.
No! No!
Oh, it's right there.
Where'd it go?
Yes.
Oh, bring that back. Bring that back. I thought I lost the ball.
It
All right.
seems to be of a magnetic material.
Ah, yes, there is. Right underneath here, there's a magnet, all right? There's a magnet underneath here, all right? Which is how, I know, this is how a mass spectrometer works. So different elements, they shoot through, and they kind of see how they go through, and they build a graph. So a graph may look something like this. So like for, let's say, I don't know, oxygen, there'll be different lines, right? And the majority of the lines are going to be around 16 for a molar mass. But there's going to be some at 14 and some at 17. And if you looked at a graph, you could figure out what the average atomic mass is from a graph like this. So you guys will come across that. I just wanted to kind of show you. Actually, the 16 should have been the tallest line because oxygen has a mass of 16. So that's how they do it. That is basically how a mass spectrometer works. And it's just kind of fun because there's a magnet on there and you guys didn't know, so. I know. I know that you're completely mind blown, but it is a cool little demo. So, today we are finally getting to true stoic. We are getting to real stoic.
Is that wannabe stoic that we were doing?
I mean, it was okay, but like, the real stoic is defined as mass to mass. All right, so mass to mass relationships. So this is how stoic is actually defined. It's a mass to mass relationship. And stoic must follow which law? It has to follow the law of conservation of matter. Went to Ramsar's last night. Got this new climby thing. It's like really cool. I got a picture I got to show you guys. So this was the picture of me after I climbed to the top of it. It's like legit really big.
Wow.
Yeah, like people are gonna break their arms on this thing. Like, and then like that was me at the top. And then I just showed my wife this. I have to show you guys this. I was trying to do like a video at the top and saying like I'm king of Ramsires. I was gonna try to flip the video, but this is how it turned out. It turned out horribly. Look at this. King of Ramsires. You can't even tell. That's it. Like I'm way up high. It was supposed to be like flip, but I didn't flip it because I couldn't see because it was so bright. So it's literally just me. You cannot tell that I'm like King of So yeah, King of Ramsires. That's the whole video. So, anyways,
That needs to go in your YouTube slideshow.
it does. King of Ramsires at the end. Okay, so here we go. This is why we should just, how many grams? So here we go. How many grams? You guys have your yellow sheet? Get that yellow sheet out. Of KNO2 are produced when 17.29 grams of KNO3 decomposes. So this would be kind of an intro level question. So how many grams of KNO2 are produced when 17.29 grams of KNO3 decompose? The first thing you have to know whenever you have a problem like this, I did this on purpose, if you're starting out with an 8, some kind of 8 decomposing, all you have to know if it ends in 8, it always ends up going to ite plus O2. So that's just kind of a little side note. You're starting out with something that's an 8, like a potassium, for here we have potassium nitrate. It decomposes into its ite plus O2. So we're going to write our equation first. KNO3 is going to decompose into KNO2, potassium nitrite, plus O2. So 8 goes to ite plus O2 anytime you got one of those. So quick balance that. So balance that quick on your own. Make sure you got it balanced. And if you don't balance it right, it kind of messes you up for the rest of the problem. You guys got 2, 2? Yes? 2, 2, because I have 6 oxygen here. 2 plus 2 is 4 oxygen, plus 2 is 6. Yes?
Yep.
Okay. So now we can actually do the stoic. So we're going to start out with our 17.29 grams of KNO3. And we know from the first part of the notes, what's the goal? The mole is always the goal, right? Yes, from the first half of the notes? Yes? So the first thing I want to do is get this to moles of KNO3. So what is KNO3's molar mass? 101.102. So I got 101.102 grams of KNO3 in 1 mole of KNO3. The next step is the most important step. The next step is the stoic step. All right? The stoic step is also known as the mole ratio. So this is where we're going to look at the ratio of moles from the problem. So in my problem, how many moles of KNO3 do I have? 2. So for every 2 moles of KNO3 in the scenario I have, how many moles of KNO2 do I have? 2. This is the stoic step. So that is how you go between compounds, the stoic step, the mole ratio. If you can get to moles, you can get to anything in the problem. And now I'm going to go back to grams of KNO2, right? So now on the bottom, I'm going to have 1 mole of KNO2 is to, what is its molar mass? Not on the sheet? Okay, I'll just tell you. It's 85.103 grams of KNO2. Get out your calculator and solve that. Save yourself some work. Do you really need to include this in your math? No, I would just skip that because you know it's 1. So I would do 17.29 times 85.103 divided by 101.102. You have to multiply first and divide second because of your dear Aunt Sally, right? PEMDAS, I know. PEMDAS is how they do it now. But I learned, please excuse my dear Aunt Sally, when I was in school. PEMDAS, order of operation. PEMDAS, yes. You guys are looking at me like, what is he talking about? Yes? Okay. You went, please excuse my dear Aunt Sally?
Yeah.
But then I would like
PEMDAS is just faster.
Yeah. Whatever. It's just like Pluto not being a planet. Come on.
Pluto has to be a planet.
It's not
I
like
mean, it's
bothers
not,
you every
but
day.
Unfortunately.
Something cool about space, NASA just communicated with Voyager 1 the other day.
Really?
They fixed something on it, and it's a 22-hour lag time because it's so far out of our solar system now. They're still communicating with Voyager 1. It's insane.
22 hours.
Yeah, one of the computers started sending a bad data round back, and it flipped to one of the other computers. And think, these are like 1960, 70 technology, and NASA's still able to send the commands to make it work.
That's so fun.
Yeah, NASA's awesome.
Didn't
It
they say
is.
that they're doing the rocket Saturday?
Tomorrow, 2:15. Yeah, as long as it doesn't lightning.
Clear your schedules.
Yes.
What's the name of it? Artemis is going on.
How many sig digs?
4.
4. What'd you get?
14.55 grams.
That's what I got. 14.55 grams of KNO2.
What did I do?
Probably calculated wrong. So do it again. Okay. So that's just a regular intro. Let's do a different one. How many grams of calcium chloride? How many grams of calcium chloride? It's going to be a beautiful night for the football game again.
Oh, I got it.
Good.
No worries.
Are produced. How many grams of calcium chloride are produced when 33.29 grams of iron, you see what I'm doing to you? Iron 2 chloride, 33.29 grams of iron 2 chloride completely, that's important, this word is important, completely react with, this next part's important too, excess calcium hydroxide. So, the important words here are completely and excess. So, whenever you have completely reacting, okay, I know I'm going to use all of it up. That also tells me that it's the limiting reactant. But we'll talk about that more in a second. So what I'd like you to do is write an equation, balance it, and solve it. So this is going back to last chapter. You have to be able to write formulas correctly. So write the equation, write the products, write the reactants, balance it, solve it. So this is really excess just means there's extra left over. Basically, you're solving this the same as what we just did. So there's a lot going on here. I'll get the door.
What does the excess mean?
Just leftover. There's going to be some leftover.
Okay.
Are your reactants correct?
Yeah.
Yes? Okay. Keep going.
Is that CO2?
FeCl2 plus Ca parentheses OH2. So now you have to think to yourself, what type of reaction is this? Of the 5, this is double displacement, right? So this is taking the notes from the first half. There's a lot involved here. Like this, that's why the chemistry is fun, because it keeps building.
Yeah. I wrote chemistry.
Because there's two, because
There's
there's
second.
iron.
You know what's double displacement? Because you got 2 compounds. Yes.
Oh, yes,
So
there
now
is
it's double displacement because it tells you what's produced and then the other stuff can't just like disappear.
Pretty much, yeah. Multiple ways to know. So I know that iron and calcium are going to switch spots. So this gives me FeOH2 plus CaCl2. Yay?
Yeah,
Yay.
I did it.
Okay. Balanced?
Yes.
Already balanced. And I like to write what I've got. Okay? So I have 33.29 grams of this, and I want to know grams of this. So I kind of like to set it up like that. It just is a little bit nicer so I know what I'm doing. So here we go. Now it's just like last time. 33.29 grams of FeCl2. Get that to moles. Eric, what's the molar mass of iron 2 chloride? I think they're alphabetical. Yeah. I think it is. Got it? 126.753 grams of FeCl2 in 1 mole of FeCl2. Next step is my stoic step. I've got 1 mole of FeCl2 for every 1 mole of CaCl2. So for every 1 mole of FeCl2, I've got 1 mole of CaCl2. I'm just going to box it one more time so we know that's our stoic step. And then I'm going to go to grams. 1 mole of CaCl2 is what mass? 110.986. 110.986 grams of CaCl2. So put in your calculator. How many sig digs will your answer have? 4. We'll have 4. Aubrey, what'd you get? Sorry, I'm not rushing you. That's what I got. 29.15 grams of CaCl2. 29.15, that's a point, grams of CaCl2. So, that's the basics. Now, we have to understand the idea of a limiting reactant. So we have to understand what a limiting reactant is, and we have to understand what an excess reactant is. So let's just define it. A limiting reactant is, I like to say, the ingredient, we don't call them ingredients in chem, / reactant. Okay, the ingredient / reactant in the reaction that limits what is produced. Believe it or not. I mean, it's hard to use, they say not to use the definition, the word in the definition, that's what it is, all right? It's the reactant in the reaction that limits what's produced. It's the one that I don't have enough of, right? So I will run out of this first. I will run out of this first, the limiting reactant. The excess reactant is also exactly what it sounds like. The excess reactant is what's left over. It's what's left over. So, let's do this in terms of monster trucks. All right? Because who doesn't like monster trucks? If I have 3 monster truck bodies, anybody know any fancy monster truck names? I still know a lot of them. No, that's the brand. Like the names of the monster trucks. Gravedigger, come on. Do you guys know any of these?
Mine, I'm related to someone who was Samson or something.
Oh, Samson, yeah. Gravedigger, Samson. This was a big game I played on my PC when I was in high school. It was called Monster Jam. It was an awesome game. If I have 3 monster truck bodies and I have 14 wheels, and I asked you, what is the limiting reactant? What would you say? The bodies, right? My limiting reactant is my bodies. Because how many wheels go on a monster truck? 4. I have more than enough wheels to keep making more bodies, yes?
Yeah.
So, what is my excess? My excess are my wheels. And if I asked you how many wheels are left over, what would you have to do? You'd have to figure out how many wheels you used, yes? Right? How many wheels did we use with our 3 truck bodies? 12. How many did we start with? 14. So 14 minus 12 is I have 2 wheels in excess. If you think about the chemistry like that, it's going to make a lot more sense. Okay? So let's do this with chemistry and not monster trucks. Here we go.
Ruining our fun.
So, I'm just going to give you the equation this time, so we're saving time. I've got FeCl3 plus CaOH, parentheses 2. That's going to give me FeOH3 plus CaCl2. Balance that quick. Balance that quick. And I'm going to start out, while you're doing that, I'm going to tell you what we're starting with. Grams of this. Grams of this. Is bouncing coming quicker? No? I would think least common multiple, right? What's the least common multiple between 2 and 3? So 2, 3, 2, 3. That's going to work most of the time, right? Least common multiple 6. I mean, you could list out everything under the arrow and kind of balance them one at a time if you need to in the beginning. So here's what I'm giving you. I'm going to say we have 72.16 grams of iron 3 chloride. And we have 34.17 grams of calcium hydroxide. I want to know how many grams of calcium chloride can be produced. So I will ask you the following 3 questions. Number 1, what is the limiting reactant? I will ask you what would be produced in theory. So in theory, in a perfect world, how much of this should I get? And also, how much do I have left over, excess? It's actually the exact same as the monster trucks, just with compounds. So, where are my CP Chemers? Okay, in CP Chem, the way Silvaji taught you to do this was she would run grams of this to grams of this, and grams of this to grams of this. Whichever one makes less is your limiting reactant. Would that work?
Yeah.
Yes. Is that how Bolsinger does it? There's a shortcut.
Oh.
All right? So this is a little more conceptual, and some of you might not get this right away. That's okay. But what I like to do is run both of these things to moles. So here we go. We're going to start with our 72.16. The mole's the goal. That's why I said that. 72.16 grams of FeCl3. So, molar mass of FeCl3. You got it? 162.206 grams of FeCl3 in 1 mole of FeCl3. We're going to solve that in a second. We also do the same for calcium hydroxide. So I've got 34.17 grams of CaOH2. Calcium hydroxide is 74.094 grams of CaOH2 in 1 mole of CaOH2. Solve both of those moles. Solve both of those moles quick. think we're going to get through this. I think we are. What'd you get for moles FeCl3? 0.4449, okay? Moles of FeCl3. And how many moles of CaOH2? 0.4612 moles of CaOH2. All we have to do at this point is look at our mole ratio. I know that for every 2 moles of this, I must have how many moles of this? 3. Or for every 1 mole of this, I need how many moles of this? 1.5. Yes? So I'm going to use my 1. For every 1 mole of this, I need 1.5 times worth of this, right?
Yeah.
What is approximately 1.5 times 0.4? Around 0.6, right? Yes? Do I have 0.6 of this?
No.
That's my limiting reactant. That's it. All right? It's going to take some thinking. Let me do that again. Let me do that one more time. All right, it's a conceptual way of looking at this. Let me do it again. So, I know that for every 2 moles of this, I need 3 moles of this. Or for every 1 mole of this, I need 1.5 times of this. Yes? So, for every 1 mole of this, I need 1.5 times of whatever this number is of this. Yes? So, I'm going to do quick math in my head and multiply this approximately by 1.5. 1.5 times 0.4 is 0.6-ish, right? I do not have 0.6 of this. So that is my limiting reactant.
And if you had 0.6 of it, does it
If I had 0.6, then guess what?
Yeah,
This is the limiting reactant.
okay.
And guess what? If it's a 1-to-1 ratio, guess what my limiting reactant is? A smaller 1. That's it. All right? That's all. That's all you have to do. It's just kind of more conceptual. And if you hate that and don't like that, you can keep doing it the other way. But the other way works.
They're both very nice.
But this just is saving time. And for like the length of problems, it really helps. And we'll do more. We'll do more. So I know what my limiting reactant is. We've completed the first part. Now, how much is produced in theory? The nice thing is, I'm starting with moles at this point. So, I know, that's why this is also kind of nice to do like this. So I'm going to use my limiting reactant, 0.4612 moles of CaOH2, and I have to run this to grams of CaCl2. Because in theory, I'm going to use up all of my limiting reactant, yes? Yes?
So that's why you start with it.
So you have to start with the limiting reactant and run it to what you're trying to figure out. Got it?
Yeah.
I'm teaching good here. All right? So I can go straight to my stoic step. In my stoic, I've got 3 moles of CaOH2 is to 3 moles of CaCl2. And then run that to grams of CaCl2. So 1 mole of CaCl2 is what? 110.986 grams of CaCl2. That will give you your amount of product produced in theory.
What is the 7 above?
What you talking about?
Like, you know how it's a gram?
That's a question mark. That's question mark.
That's just question mark. That's question mark grams.
Oh, that's question
Sorry.
mark?
See, I got
That
put
was
7 there because I
How
thought-
many grams? Sorry.
Okay.
Very bad question mark.
I just thought it was
That's
7,
question
so
mark.
I
Thought it
used
was
that
a 7.
instead
Yeah.
of-
No, that was question mark. What'd you get for your grams?
51.19.
I got 51.19 grams of CaCl2 produced in theory. 51.19 grams produced in theory. How's this going, Marin? How you like this?
It's a lot.
It's a lot.
easier.
A lot easier?
Yeah.
Good.
I don't know if it was just 'cause, like, last time it was the first time that I ever saw it, because I
Yeah.
did physics as a freshman.
Right.
But it was like I did not understand it at all.
Good.
Like I just couldn't get it.
Good.
But now it makes sense.
Good. Awesome. That makes me feel good. Then the last thing I have to do is my excess, right? So we have to subtract our wheels, right? In order to subtract the wheels, we first have to figure out how many wheels we used, right? Yes? So, guess what I'm starting out with? I'm starting out with my limiting reactant. So my limiting reactant, so I've got 0.4612. This is why it's so nice just to run it to moles, because I'm always starting with moles. Moles of CaOH2. And I have to run this to grams of what? Grams of the other thing, right? To see how much I actually used. Yes? So I'm going to run moles of this, 2 grams of this to see how much I actually used. So, go to my mole step, my stoic step. I've got 3 moles of CaOH2 is to 2 moles of FeCl3, and 1 mole of FeCl3 is a molar mass of, we already have that up here, which is nice, 162.206 grams of FeCl3. So that will tell me how much were used. How many wheels did I use? I have to base that off of my limiting reactant. Just like our truck bodies. I knew I had 3 truck bodies, right? So I had to run my truck bodies to my wheels, is what I just did here. So how many wheels or grams of FeCl3 did I use? 49.87 grams of FeCl3 was used. 49. I had 49.87. Now what do I have to do? Subtract. How many wheels did I start out with? Yeah, you got it. 72.16 grams of FeCl3. Oh, I hope that's still recording. Oh boy, hopefully it's still recording. 72.16 grams of FeCl3 minus 49.87 grams of FeCl3 will give you the excess. So, what'd you get? I got 22.29 grams of FeCl3 in excess. In excess.
I forgot how long these problems.
I know. That's why I said. That's why I said over there. Okay, you've got some work. You've got some work. Let's do one more. I think we can finish this. We've got 10 minutes left. If you don't have more than half a page, you're gonna have to flip the page. This is about a page of work. So, this, what we're about to do, will be about as far as you have to take this. Okay? So here we go. How many grams of barium phosphate? How many grams of barium phosphate are produced? That's what you do with the dead scientist. Barium. Sorry. 61.3, boron, you boron. 61.32 grams of, I know, I'm here all day, folks. Barium chloride. So how many grams of barium phosphate are produced when 61.32 grams of barium chloride react? Whenever you see react, are you thinking plus in your reaction? Okay, think plus when you see react. With 27.29 grams of phosphoric acid.
A little bit of everything.
This is a little bit of everything.
Is that 27 or 29?
So, also, find excess. All right? You know you have to find the limiting reactant, right? I don't even have to tell you you have to find the limiting reactant because I've got 2 things to start with. You don't know what the limiting reactant is. When I'm saying how many grams of barium phosphate are produced, I'm saying how much grams of barium phosphate are produced in theory, right? So take a few minutes and work this through. Unfortunately, if you mess up the balanced equation,
Everything.
you are screwed. I don't know, like,
Everything.
that's the only good way to put it. Like, you're in trouble. So, first step, write the equation. First step, write a balanced equation. At this point, we're into second semester of CP Chem, so
Second semester?
I'm pretty sure the midterm was a limiting reactant lab.
And periodic trends.
Yeah.
Oh, I thought you meant.
That's how Ian was. He
Yeah.
transferred out of this last year, and he's like, "We did this."
So we are 11 days into AP Chem and a semester
yeah.
into CP Chem.
Ian came in and was like, we've already been through half.
Yes.
Yeah, it's like I'm already halfway.
Which
through.
as of Tuesday, I'll be teaching 2 sections of CP Chem. So, yeah.
Interesting.
Yes.
Sometimes I'm curious how that works, like how you're able to shift stuff around and stuff.
It was luck, in all honesty.
Oh.
Just the way our schedule worked out. A bunch of stuff switched, and it didn't change the master schedule. So
Wow.
we just want everyone to be successful. That's all there is to it. And the current setup was not successful.
Very much.
Okay, wait, this is what I messed up on. Acid is H.
Phos, yes.
So
Something like
phosphate.
Hydrogen is the cation.
Is ick.
Phosphoric means it had to come from
Fate.
phosphate.
Okay, so then hydrogen goes in front of it, right?
Yes.
It's on the other paper as well.
Yeah, I want you guys to have a chance to do it first. I will give you the equation just to make sure you guys are on track.
Maybe we use a pencil.
Yeah, pencil's not a bad idea. All right. BaCl2
Oh, I already messed up.
plus H3PO4. I only know that because I got my ions memorized. PO4 is a -3, right? Gives me hydrochloric acid plus Ba3PO4 parentheses 2. There's my balanced equation. So, well, it's not balanced yet, actually. That's the equation. To balance it, I got 3, so I got to go 3 here. Is this 3, 2, something? 3, 2, something, 6. There you go. That's balanced.
Oh,
Where did you
shit,
get
I'm
the
smart.
Why is it just
HCl from?
Because hydrogen and barium switch spots. Hydrogen is a +1, chlorine's a -1, right?
But where is the 3 and 3 go?
So remember, when you are making names and formulas, it only comes from the charges on the periodic table. So for HCl, hydrogen's +1, chlorine's a -1, right?
Yes.
That's a perfect match. We don't care about these subscripts. These don't go anywhere. This is only here because barium, right, was a 2+ and chlorine was a 1-. Those crisscrossed. The subscript just depends on what it's matched up with. Question?
Yeah, so like with the products, does it matter which order it's in?
No, it does not matter. You could have written Ba3PO42 plus HCl, does not matter. Good question. So the subscripts come from the charges. Or unless it's like a diatomic, it just because it's a diatomic. Good question. that's a big old compound. Just imagine if you had to make the molar masses of these compounds.
I would cry.
We don't have time for that.
Yeah.
Once I figure out the moles and I see how close those numbers are, I know the limiting reactant's going to be pretty easy, right?
Yeah. Whichever one's
Did you guys get the limiting reactant yet?
Yeah. I think so.
Did you get BaCl2?
Yeah.
Good. So, finish this over the weekend because we're out of time. So over the weekend, get your how much was produced in excess, how much was produced in theory, figure out your excess. We'll quick finish this up on Monday and then go into lab. I mean Tuesday. Go into lab.
When's the write-up for this lab that we just did?
Wednesday. I didn't want to make it due after the weekend. Yes.
For the lab write-up, is it the same stuff that we had to have for the